let's take a look at what we've done so far on building this 4 shipping container lounge with this shipping container build. It has been absolutely crazy. We've been moving quite quickly. With this shipping container build, it has been absolutely crazy. We've been moving quite quickly through the build. We've cut and framed the shipping containers, we've reinforced the interiors, we've built 2 staircases. So far we're moving up to our terrace. We're doing all the logging on the inside of the shipping container, moving on to our electricals also. Little by little the build is coming together. Let's take a look at what we've done so far. So far we have painted the unit, as you can see. Let me show you what we've done on our staircase. The staircase was actually a part of this that was a little bit tricky. Now, when it comes to putting a staircase or running staircases for a shipping container build, what we try and do is use the shipping container as best as possible, or you can reduce the amount of materials that you're using for the building itself. What we do is that we build the staircase onto the shipping container. By doing this, we eliminate the need to use reinforcements on one side of the shipping container. You can see what the reinforcement looks like here. This is an H-beam or an I-section. This carries the weight of the staircase going up. The staircase itself is built with a variety of materials. I'll run you through what we use to build our staircases shortly. And like I said, running the staircase onto the body of the shipping container, eliminating the use of these I sections on one side. This helps us to reduce the cost of the stairs and also use the shipping container as best as possible, because now you can run the entire, you can run the staircase and just put it directly onto the body of the container itself. The container itself is made out of steel beams at these corners here, one at this corner, one at that corner over there. We have two shipping containers side by side here, giving us quite a lot of room or place for us to put our staircase. Building a staircase like this requires a variety of materials. Some of the materials that we use, in view of where we are, you can build a staircase in a number of ways. But like I initially spoke about, I sections are a big part of what we do when we're building staircases. These carry the weight of the staircase itself. The staircase itself is made out of steel C channels. These carry the sliders going up, or the risers going up. These are the C channels here, one over here and one over here. Then also for the risers themselves, which are what you step on, these are made out of angle steel and also checkered plates. The idea will be to create yourself a box like you've seen there, put a bit of checkered plates on top of it, and then you have what is a riser. All of this is done going up. Then once you get to the first level of the staircase itself, let's see. Once you get to the first level of the staircase itself, then you have another reinforcement required, which is the landing area of the staircase itself, which is made out of H-beams, just like we would for the supports. This material, we take it, we put it down here, and then we put a piece of checker plate on top of that. That is repeated all the way across here. So once you get to the next level, going up again, you have C channels, angles, checkered plates, all the way going up till you get to the next landing again. And that is how the staircase is done all the way to the top. For our railings, we go in with 1.5 inch round galvanized pipes and 3/4 galvanized pipes to give it a nice, cool, clean industrial feel. All of this is welded into place, grinded and puttied, and then by the time we're done with this, it will look really, really dope and match what we're doing with the rest of the building. Another aspect of the build that we've done is gone ahead and sprayed the entire shipping containers. We've done a full cover with enamel anti-rust paint, and this starts to really protect the shipping containers from all the rust that can accumulate once you start to cut and weld. You can just take a look at where we are right now. You can see we're right beside the sea, and it is absolutely crazy. This is like worst case scenario for any type of building, but shipping container buildings work really well here, even though you have the sea air, which is quite caustic, blowing onto the shipping container. Once we are building a build like this or build of this size, we cut, frame, and then we quickly spray the shipping containers with anti-rust paint. Like I initially said, this is an enamel type of paint that leaves a really nice matte finish. And this is basically the type of paint that is used on the shipping container itself. That is the original paint from the factory. For the shipping containers, we utilize the same type of paint to paint on this. What does this do? It does a couple of things. You don't mix paints and then have the paint start to react with each other. Another thing is, you're using the best type of paint. Like I said, an enamel-based paint for the shipping container, which is the best type and protects it for as long as possible. Another thing is, of course, you're stopping rust from developing on the shipping container itself. Now we've done this all across the build itself, all the way around. There are still little places where we still need to cut or weld, maybe to pass in our electricals or to reinforce. Once all the cutting or all the processes of cutting the shipping container is completed, you can see those areas here, where some welds are still going on. We're going to now come back in and do another treatment of the shipping container to completely cover the entire unit before we can now start to finish it. Now, this stairs, which is being currently constructed, we've already shown you how we've done this. Let's take this stairs upstairs and take a look at what's going on the roof. Now, when you're building a shipping container, when you're going up with a shipping container, nobody will show you how it looks from the under of the shipping container. You can see it right here. Absolutely crazy, isn't it? You can see where the containers are joining. And look, containers they're not always straight. If you're not buying a new container, they're not always straight. So, they might be banged up and stuff, but the idea would be to ensure that you have a nice and clean stack. Once you have that, then you can quickly tie them together. Let me show you how we tied in these containers. You can see all we've done here is, like I said, stack the containers themselves, and we ran a a clean weld across inside and along the sides, and also on the bottom also, to encompass the entire joinery of the shipping container. This is not where it ends. There's so much more reinforcements to keep the shipping containers together. Let's take a look as we go upstairs. As part of joinery of the shipping container, you can see we're right on top here. You can see where the shipping containers have been joined together. We've joined them here on those posts. We've welded it around. We run a flat bar all the way across the shipping container. What does this do? This ties in the shipping container on top also. You can see it here all the way down. It runs all the way down the entire unit, all the way down to the end. And once we do that on top here, we also, on the bottom area of the shipping container, we also reinforce and tie that in. You can see that we've dropped, on the inside, we've dropped the walls that are touching on this line, on this level. And that means that, you know, you have a less structurally integral aspect of the shipping container. So what do? We tie it in with a flat bar on top there. You can see how this looks on this side here. You can see how it looks here. Really nice, really easy. This is container 1 over here. This is container 2 over here. And basically, once you put them in, we weld them into place. And to stop, you know, water or anything running through the middle, we start to run a flat bar to seal it up like a band-aid all across the edges. You can see how the reinforcement looks here, or how we seal the containers or join them together. This is where the two containers meet. You can see the flat bar that we've run across here. That flat bar goes all the way down and also across the seam on the ground. All the way, you can see all the way down, all the way down. This hasn't been fully done. This is just like a temporary one, but then we're going to run a seam all the way down the entire unit like this. And then that really starts to tie in the shipping containers. You can see it, as I said, it upstairs also. You can see it up the reinforcement underneath the shipping containers themselves. That also joins the shipping container together. We are 4 weeks into this build. Let's take a look at what we've done so far on building this 4 shipping container lounge. Now you're looking to build a house. Which one would cost you less, building a shipping container or building a house made out of brick and mortar? We'll take a look at a few similarities between both and differences in this video. Let's go. Before we talk about the differences, or what the main difference is, we'll talk about the similarities. There's a lot similar between a shipping container build and a typical house. Basically, everything that goes into a shipping container house goes into a typical house. You're going to need electrical, you're going to need plumbing, you're going to need light fittings, you're going to need circuitry, you're going to need drywall, you're going to need finishings, you're going to need stairs. Look, I'm coming down the stairs. You're going to need stairs. In your typical house, you're going to need flooring on the inside. You're going to need a door, you're going to need windows. Basically, everything that goes into a typical house goes into a shipping container build. Now that we've addressed what the similarities are, which is virtually 98% of the entire building or both buildings, then what is the main difference between a shipping container house and a brick and mortar house, or basically any other type of building? It is basically that a shipping container already has a floor, walls, and a ceiling. You're buying a complete box that is already very structurally integral once you stack it the way we've done back here. So with that, you start to reduce the amount of man hours it requires to build the shell of your building. And that is where a lot of your money goes into. A good percentage of your budget goes into building up the shell of your building. Now, the shell. What is the shell? The shell of your building, for you building with brick and mortar, that will be all the brick and mortar you set into place. Your foundations, the brick and mortar you put into your posts, the brick and mortar you put in to arrange your walls, the brick and mortar and the concrete you put in for the lintels. All of that forms the skeletal of your brick and mortar house. But for a shipping container, all of this is already made in a factory. And once things can be made in a factory or done in a factory, it starts to reduce man hours, make things more efficient, and eventually saves you more money. So for a building like this, we are 4 weeks in. We already have the shape of the building. We're currently doing quite a lot of things on the inside. We have staircases ready already. And you can't beat that time. You can't beat that time in terms of how quickly you can deploy a shipping container build. Now, there are other methods of construction that are even faster than shipping containers. But predominantly, looking at shipping containers and how much available they are, they're very, very enormous resource. So you can get them anywhere. You can get them in most places. And basically, they are available for use for building. So one building with a shipping container house, it just saves you a whole bunch of time. And by saving time, you save money. We can't juxtapose this enough, or we can't compare this enough. If you save on time, you can save on money. If you save on labor, you can save on money. Now, if you see how many people we have on site here today, we've barely had 10 workers working on this building so far, and we are close to about 50% complete. The rest of the building involves finishing, the finishing aspects of the building that, you know, really starts to tie the building down and make the building, you know, what it should be. And these aspects also are handled by singular or a few professionals. But for that initial stage, setting all of this up versus a brick and mortar build, you will have required close to 40 to 50 people to, you know, put this together, you know, foundation works, bricklayers, setting it, all of that, arranging blocks, the decking on the top. You know, for this we have 2 deckings, which we didn't need to wait or cast anything. All of this was set up in a couple of hours. So that is basically what the main differences are between a shipping container build, and that is on the skeletal part of it. What is the difference between setting up foundations for a shipping container build versus a typical brick and mortar house? Shipping containers, because of how they're set up, it's a structurally integral unit. That means that it can support its own weight once you support them on 6 corners. This is a 40-foot container. This shipping container can also be stacked. You see them stacked at the ports 8 high. You have no problems with that. For shipping container building, since it already has a reinforcement holding up the weight on the sides and also on the bottom, the types of foundation that you require for a shipping container build versus a typical brick and mortar house is very, very different, especially in the amount of materials that you need. For a shipping container build like this, you only need to support the shipping container in 3 areas. That is at the beginning, at the middle, and right at the end. For this, we've done it in 4 areas. We've also taken another step because of, you know, the shipping containers are going up. We've tied the shipping containers into the foundations themselves. In terms of material use for this construction versus a typical, for a typical build, we're talking about more than 80% in savings in terms of the materials used to set up the foundations for this build. That is another way a shipping container build will save you money on those foundations. For a typical build, you need to go with a raft. If it's in a swampy area, that raft is going to be super thick. So, you know, that will set you back a lot of money. You see foundations running into the millions. So for this and a building of this size, to be able to have strong foundations and not still need to spend all the money or spend a whole bunch of money on buying materials and pouring it down here, then I think that is a cool thing that you get with shipping containers. So even if the shipping container itself might be expensive, you know, buying this might be expensive, setting this up might be expensive, it will help you to make savings in other aspects of the construction later on. Now, how fast can you build a shipping container house? When building a shipping container house, I mean, this stuff goes really fast. Shipping container already has, like I say all the time, floor, wall, and ceiling. With that, you don't need to start to build it from ground up anymore. You basically have to set it on the foundation and simply skip into making doors and windows for the space. And that speeds up the process of building any structure. Now, can you guess? Oh, I want to build a 2-bedroom house. And you can say you can build that 2-bedroom house in 4 weeks, 6 weeks. These timelines are timelines that you cannot get with any other type of construction. I mean, it's like out of this world, because like I said, you're mechanizing, you're making the process more efficient. You're not having 200 people walking around the site. You understand? Coordinating all of that, putting that together, that takes time. And with time, things get more expensive. So with a shipping container build, because of the way a shipping container really is, building it or setting one up takes very, very quick. Another aspect of why shipping container builds are much faster to build than typical housing is that they require dry construction materials, POP boards, cement boards, materials that do not need time to be processed to dry. You have the logging on the inside. All of these things are buy, cut, fix, and that speeds up the process also. Another reason why shipping container builds are quicker to build is because of the foundations required to set one up. A shipping container does not require a type of raft foundation. It requires plinths that we've set up here. Even though these go into the ground, they do require like plinths, and you don't need to have all that material here that you use to build a raft here. So you have foundations that can be built in as little as 5 days, and that again speeds up the process. Things are going up in the market, so you know, I want to build fast, I want to build quickly, and that is what a shipping container does and helps you out. Another reason why a shipping container house will be faster to build is that this entire shipping container build can be built in a factory. You can prefabricate this entire building, bring it to site, and even speed up the time required to build this even more. Because by prefabricating a unit, you can control everything that goes on in a controlled environment. You can increase the efficiency of processes. Like now, today's a Monday. We're here right now. Most of the team hasn't resumed because we're on site. Imagine you were in a factory. You'd have timelines, all of those things set up. You have machinery to help us out here. And basically, that would speed up the process also. Another reason why a shipping container build is faster to build or much quicker to build than a typical build is that it is mechanized. You can mechanize the entire process, and of course it requires less labor to build. So basically, when building a shipping container house, because you require so much less labor, and because all that labor that you would normally need in a typical build, you've mechanized it, you can make the entire process much more efficient and quicker. Let's go. Which other things are we talking about when it comes to shipping container builds? One thing I think a lot of people ask about is the cost. You know, cost is a big factor when it comes to, you know, building anything, and people always want to know how much it costs versus a typical build. We cannot run through the entire process in this video because there's a lot of things, there's a lot of similarities, and there's a lot of differences between them. But then let's just run through quickly how much a shipping container costs. How much is a shipping container? I want a shipping container on my piece of land. What are the fees or prices that I need to think about when I want to buy a shipping container? It's heavy, man. But these gents, man, they're crazy. Woo. But bro, I'm helping them. Don't get twisted though. Look at that. And Jen is in place. Getting a shipping container on your land or getting a shipping container to your property involves three main costs. But those three main costs, there's one more, especially if you're in Nigeria and you're in Lagos. I'll tell you about that last one at the end of this video. Number one cost is the cost of the shipping container itself. How much will the shipping container cost you? Where do you buy it from? You can choose to buy a shipping container from individuals, people that ship containers, and you can buy them from shipping companies or at the ports. We choose to buy them at the ports because that's the source of all shipping containers. Number one, like I said, the price of the shipping container. Number two is the transportation for the shipping container, the logistics, everything that you would need to unload the container from the ports onto your transportation, the transportation process to your site, and then offloading the container on your site. Those are cost number, I think, 2 and 3. So number 2 is transportation, number 3 is offloading. And that is different in terms of what size of shipping container you have. So basically, if you have a 40-foot container, you have 3 costs to contend with, which is transportation, cost of container, offloading, because this shipping container or shipping containers, 40-foot shipping containers, require an extra piece of equipment to offload them. For these ones, we use cranes to offload and stack them because of the configuration of the building that we're going for. But you can always use an IAB, you know, smaller one to offload it. But for a 20-foot container, you need to think about 2 costs, which is the cost of the shipping container and transportation to your site, because a shipping container normally is carried with a type of truck that has its own crane on it, and then it can easily be offloaded. In Nigeria, the fourth one that we spoke about is, I put it under miscellaneous, we'll call it omonile. Yeah, I know people know who omonile is. When you're carrying big goods or stuff, there's a type of levy or tax that you have to pay when you're bringing them into most places. That tax is I don't think it's negotiable. You know, if you don't want to have any problems, I think that's the saying. Give unto Caesar what Caesar deserves. So yeah, that's saying. You get it done. That fourth cost, like I said, miscellaneous. These prices range depending on where you are. Places on the mainland, different, places on the island, different. You just have to know the particular region in which you're taking the shipping container to, and just have a little bit of a budget allocated to that. Depending where you buy your shipping containers, a 40-foot container can run you up, let's say about 1.5 million, all the way up to about 2 million, 2.5 million, depending on who's selling it, depending on the quantities that are available. All depends on what's going on in the market prices, you know, dollar, all of that stuff is all plays a part in here. So prices are not always fixed because they move around quite a lot. But a typical container like this could set you back about, well, maybe about $2,500 and above here in Lagos. Like I said, those prices are very, very different wherever it is that you are in the country. Another aspect that would affect your cost of the shipping container is how close you are to the shipping container. So if you have to buy a shipping container from Lagos and then you're having to transport it all the way to Kaduna, you can see that that's going to be a cost on the logistics. If you're buying it in Lagos, you're in Lagos, you know, much closer, logistics will be less. So these are some of the things that you look at when it comes to the price of a shipping container. Okay, so I think this one is just going to be like vlog style. I'm tired of doing it from the head. Let's go through what we're doing on site today. So much has gone on in the last couple of, I think about a week or two, but we're still on pace to complete this building. There are numerous things or numerous processes going on today. We are currently going to be slabbing the top for the terrace, putting a slab on top of what we've constructed. I'll show you what that looks like in a minute. You can see right here we have our team laborers mixing up concrete mix so that we can take that upstairs and slab. It's going to be a proper day of moving concrete from here all the way to the top. This being probably one of the more labor intensive parts of this entire building and requires the most amount of people just because we're doing that terrace and where it is. So this process, like I said, is currently going on, and we will take a look at that alongside what we're doing on the inside, which is also the insulation for the building. So far so good. We have fully fabricated the entire building. We have knocked the interior. We've run all our roughings. We'll talk about roughings in a bit. They've been crazy. We've done all our roughings. Now that all the things behind the walls are completed, then the next phase or the next aspect of it to start to insulate the unit so that the unit starts to become even more welcoming, and then we can now start to control the temperature on the inside. Once that is done, then we'll now start to include or add our drywall to the unit. So let's take a look at how this process is going on. So basically on the inside, we have also started to do all our insulation for the unit. You can see we've done all the roughings. We have our wires in for our electricals. We have our plumbing pipes already running in. We finished all our roughings. The next stage will be to start the insulation of the entire unit. And we are using, of course, 25 mm rock wool bats that for this build we're going to double. Now let me tell you how we're going to insulate the entire unit. This unit being 240-foot containers on the floor, 240-foot containers on top, and a terrace on top of that, actually allows you to reduce your insulation by a considerable amount. For shipping container builds, once you can allow or stop direct sunlight hitting your shipping container, then the insulation you use inside your unit will be even much greater amplified. So for a build like this, now that we have a floor on top, that floor is ineffectively insulating this ground floor that we are in, and then because we have a terrace on top, that terrace is also insulating the first floor. So basically what we'll do is we would just insulate our walls or double insulate our walls because we have quite an insulated ceiling already. You can see the way we set up the top here. This entire floor is ready for our insulation and drywalling. And you can see how that process goes in. All the prefabrication has been done. You can see our partitions are in. These are some of the roughings. You can see here electrical. You can see our HVAC. Basically, everything that we need behind the walls has gone behind the walls, and then we can now start to really finish up the interior of the shipping container. But no, Oma were very, yes, but kilema lo plumb range okay. All right. So basically on the top here, we have set in our subfloor. How did we do that? We took H-beams, created ourselves a grid here, and all the shipping container sheets that we took from downstairs, we brought them upstairs and created ourselves a subfloor. Look, it's super steady, it's not even bouncing. And with this, we have what is a very good surface to now start to do the process that we're doing right now, which is the slab. As you can see, we've set in some DPC waterproofing membrane on top of the containers. We have also set in a really nice grid of reinforcements. That reinforcement would help ensure that the cement or the concrete does not crack. And basically, we are also lifting the reinforcements up with makeshift biscuits just to raise it up and ensure that that reinforcement is sitting right in the middle of the cast itself. So on this side, now that we're doing the casting, we need to find out how are we going to drain the surface of this place. We do not want water coming in and sitting on top of this surface. Instead, we want the water to come, drop, and then wash off and drain off. So basically, we've set in floor drains. You can see those here. These floor drains are going to act as our drainage areas to drain the entire top. We have them in a couple of places all across, and then we will slope the slab into these drains to ensure that the entire space can drain effectively. So the process has begun. We've started to mix in all our cement, and of course, as we labor, anything labor is always intensive. You have to see that's where the water is over there. That's where we're mixing currently. Guys have to go and carry buckets of water and move them all the way there. It's just long. So we're looking for a hose to connect from the supply so that we can have a continuous supply of water to the site area where we're doing all the mixing. Let's go take a look at what they're doing. Basically, as you can see, I don't want to stain my shoes. This is the cements that we are, or the concrete mix that we have. You know, concrete mix, same old, gravel, sand, cement. We've added a waterproofing compound to this so that we have a concrete mix that is waterproof, because we're going to be doing the terrace. Basically, that's the entire process. You can see how they're mixing that up together. We've got ample materials. We have quite a lot of concrete here that's going to be going up. So we're going to mix them in batches, batch by batch. I think we still have about 30 tons of sand over here. We're going to mix it batch by batch and then start to take it up. You can see our tap location. We're fetching this water with buckets. Man, this is going to be long. We need to find a hose. Fella, what are you saying about that hose? I think we really need to find a hose. But I think you look at it from where the water starts, look at it all the way down to where we're mixing. I think it's about, give or take, 30 to 40 meters. Let's say 30 meters all the way down to that place. And that is a long ass hose. And I'm not going to be needing this hose after this. So I don't want to buy a hose just because I want to do a tiny slab. But I think we might just have to do it just to speed up, you know, the process, because look, we're still mixing the first batch. Almost an hour has gone by, or we've not even mixed up one batch. So we've called the suppliers, right? We've called the suppliers, and you know, our supplier is going to see whether they have a hose that they can lend us. If they can't, I think we're just going to have to buy one. Yeah. So what are we doing here? It looks like we are running armored cables for the main building. For the main building. Look at the size of that cable, man. How many mm is this cable? 25 mm cable. Look at that. Now that's the cable for supply. So basically, all of this is the supply that goes into the building itself. We are running that supply all the way from that into their main generator and panels here. This is where the panels that supports the entire jetty this is the power point area here. So we're just going to run our cables. Those cables are going to be buried all across the wall and then straight into the shipping container. Baby! So now basically we've started to pour our concrete into the space, and we're just going through basically how we will slope what is basically a flat surface. How do we slope them into our drains? So we've started to ensure that we have just minute or smaller slope on that side, and ensure that we have a really nice gradient going up on this side, so that all the drains where they are, because we didn't have the drains in four corners, they're in weird areas. We have one over there, we have one over there, and two on this side. So all of this side flows into one drain, and then that other side flows into the other drains over there. We ensure that we have the slopes in the required areas so that everything on top of this surface will drain when it rains. And as you can see now, it's raining actually, so we have a good way to test if our slope is working. So basically you can see how that slope is working out. You can see how we have a little pool of water here. We just had a little bit of a downpour, and you can see that water pooling here. And this is also water that's coming from the concrete, the excess water from the concrete itself. You can see that water pooling here, and that shows how the gradient being lower on this side will collect all that water. And also this is where our floor drains are located. So this is perfectly working really well. And as you can see, we have even more rain. It's drizzling right now, and this gives us an indication that what we're doing is actually working.